Hi, everybody. Um, One of the things of being a headphone lover is the education I'm getting constantly. For example, I thought that the cables that came with headphones were all I needed. That I assumed that the manufacturers would want to put their heart and souls into a cable to make sure that we were getting the best performance from the headphones, which may well be true to some degree, but I was actually watching one of my favorite YouTube channels where I'm continually learning about this field. Thanks to Brian, our guest here from Wave Theory. At any rate, one time he was comparing headphones, what he would consider more moderately priced, and he mentioned Audiophile Ninja. And I went to the website, and this is what caught my attention. On the website, it said, "There is no magic or cable voodoo here. Leave your snake oil, fairy blessed wire, and diamond encrusted connectors at home." I thought, all right, I can definitely relate to this. And I also reached out at that point to Jeremy, who you'll be hearing tonight, because I had a bunch of questions on things. And what I discovered with Jeremy's guidance was that one of the things that do matter is finding headphones that are really flexible and the length that you want, and making sure that the connectors are really high quality. And he has all of those things. And so uh, that's pretty much all I have to say as far as an introduction, other than that Jeremy is delightful and very funny. And don't miss his YouTube video of having this third world champion, three-time world champion strongman trying to break his cables. So with that, I would like to introduce Jeremy.
Thank you, Lori. I guess I'll have to, post that video now and give the link out to you so we can let people know. I think there's a couple of people who have seen it, but yes, hey everyone, welcome. I am Jeremy Eskritt. As I mentioned, today we're going to be chatting about cables. Let me just share my screen here. I think this time we can share it. Let me know once you can see it, just in case.
I can see it.
Perfect. All right. There we go. So today is going to be informal discussion on cables. I'll go over some high-level topics, and really want to get everyone's expertise, as we go through this as well. If anyone has any questions or comments, if it's critical to what we're going over, definitely reach out, add some questions in the chat, and we'll have the facilitator take a look and ask those as we go through. This is definitely not an in-depth course that we're going to be going through today. It's really, just a very high level of cables, what goes into cable designs and some of the theory behind it, the materials, and really just a high level overview of cables and maybe things that you've never heard of before, things that can get your creative juices flowing on some of the reasons why cable builders do the things that they do, and just a really learning environment. I mean, most of the people on this call probably have been, in the audiophile world for many, many years. So again, I really appreciate and welcome the expertise as well in this room, because I know there's a wide variety of experience here. So yeah, just a casual chat on cables. We'll go over a couple of the different items. And this is, again, just a reference point. It's not everything and everything about cables, but just something to get the conversation going. So overall, today's topics, again, a high level that we put together is we'd like to review overall, what the purpose is of a cable. Seems simple enough, but is it really? And then walk through, what really defines a cable, some of the use cases of why you may want, and I say may want different cables. And then just walk through some of the different cables that we see in the audio world today. When you're hooking up your stereos and all of your gear, what are some of the different types of cables that are available, as well as what they're made out of, some of the material choices that go into it, and so forth. And then we're going to go into a deep dive of some of the cable properties. So all the things that you hear about when searching for cables, all the different buzzwords and, and understanding, what all of it means, just to give a high level overview and to really dig into some of the topics out there that you may know or you may not know. And again, that's where, I want feedback as well as after this is, what was helpful, what could be improved upon. And then, just want to learn from this group. And then we'll just do a quick lessons learned of what I've learned, in the few years that I've been making cables and how I've kind of changed and learned as I've gone through the whole process. And then just do a quick wrap up from there. So any questions before I move forward? All right. So why do we need cables? So Jim, this is what I was talking about. The one slide is, why do we need cables? Well, they're all the same. End of story. We can cut off the presentation here. But really, why do we need cables? It's really to pass electric signals from, one component in your audio chain to another. Those cables can be, passing analog data, such as actual music signals, or it can pass power. And then there's also the digital side of things where you can be sending data as well as digital audio to and from, DACs to your preamp amplifier and so forth. In the real world, directly attached cables and the ones that are shortest possible are actually the best because there's less material that signal needs to go through that could potentially impact it. But unfortunately, everyone in the world doesn't have the same size living room. They don't have the same size speakers. They don't have the same furniture and layouts of their rooms. So fortunately or unfortunately, we need cables to attach our gear, everything from our speakers to our amps to our preamps, all of our speaker cables, interconnects, and then headphones as well. Definitely can't forget about headphones that are out there. And really, cables also allow us some flexibility, to really adjust to our particular listening situation. Some people, like for instance, at my desk here, I've got different amp stacks and then headphones here. And it's really helpful to have a shorter cable at my desk that's not long and tangly, and then have a longer cable for down in the living room where I'm connecting it to an amplifier all the way across the room. So that is one of the benefits of having, pluggable and hot swappable cables is that flexibility that a lot of us are after. And then finally, we need cables because they more or less, their main design is to send a signal cleanly and without any sins of commission. Basically, we don't want anything to add to it as it passes from point A to point B. And every different cable too, what's unique is interconnects versus speaker cables versus digital audio cables. They all have different physical and material properties that are more important. So we'll get into that in a little bit later, but some cables you definitely want to have, extremely low resistance. Other ones you want to have low capacitance. And we'll walk through some of those different properties going forward. So what exactly is a cable? We'll drop it down to its basic sense. It's a conductor. It's a medium that passes an electric signal from point A to point B, making sure that the signal that it gets and goes through its medium is the same signal that gets to the very end. And each conductor is bound by its material properties, as we mentioned, such as resistance, conductance, capacitance, and so forth. And to make things even more confusing, each of those properties in turn are impacted by the size of the conductor and the length and the material it's made out of, the geometry of how it's designed. So that's why this, kind of slide is, one of the cruxes as to why there is so much, fervent attitude around cables is because there's so many different things that could impact that design, that there's a million options out there, and trying to find the right combination of materials and properties to put it all together, can be quite a challenge. And then finally, again, cables, what are they typically made of? It's more than just the wires that you need to consider. It's the connectors on both ends of that wire and how they're put together, how they're assembled, how they're soldered to make sure that the actual physical connection between those two materials are rock solid, and that it allows that electrical current to flow through it without it being impeded. And then the physical nature of wires as well. They're being moved around, they're on your desk, they're getting stepped on, you're getting chewed up by your animals. So having sheathing on there, or a level of protection and strain relief, also a lot of cables have as well for durability purposes. So use cases. So this is where I definitely want to get a couple of people to jump in at once we're done through here is, I try to think of, how do we boil it down to what do people use cables for? And what are some of the mindsets around how we use cables in the audio world? And I kind of boil it down to 4 here. Again, there may be more, a combination of them, or there may be more as well. But really, we've got the single signal purists, the people that basically they want the cable to do the least amount of damage. They want the highest purity copper. They want the cleanest signal from point A to point B, nothing to change. What goes in comes out. They want the highest, latest, and greatest technology, the purification methods for their particular wires and so forth. They want it to be pristine, and they're willing to pay for that level of purity in that wire. The second group of people is regarding to enhancing the synergy with your existing equipment. So some people want, to try to use cables to add some warmth to their music if they have, shrieky speakers, or if they want to tame some of those highs, if they have it, a little bit of grain on the upper end. And that's where some people leverage cables really to try to change their system and to really synergize with other equipment, because there is a thing to be said for synergy across all of your audio gear from start to finish. Some speakers just really pair well with certain amps, and some headphones pair well with, certain things. So, this set of group of people really is focused on changing that cable material, the structure of it, the geometry, and so forth, to make their cable really match what they're looking for in sound. Number 3, bare bones, all about functionality. They want a cable to, be professional grade, where it is a standard purity of copper, for instance. It's durable, it's going to last them a while. Very bare bones, but it does the job. It's something where, they're more focused on, this particular use case is more focused on, form and function of, is it long enough to get to my amplifier? Does it dangle on my head? Is it too heavy, for instance? Does it fit me well? Does it fit what I'm using for? And then finally, cables as audio jewelry. So yes, so everyone loves different designs, different materials, different setups for no reason. And that's what's awesome about this community, is it's what makes the world go round. Artwork that you see everywhere. I mean, art really doesn't add anything to, it doesn't have a function. It makes you happy, though. It's that whole feeling of, if it makes me feel good, I'm going to enjoy my music more. And there is absolutely nothing wrong with that. When it comes to headphones, one of the first things I tell people is, before you even listen to them, put it on your head and look for something that fits your head right, that it feels good. Because if you put on a pair of headphones, it could sound and be the best headphone in the world and have the most details and engage you. But if it hurts after 5 minutes because the headband doesn't fit your particular head, if you got a wonky head, or, like if you've got big ears or something and you're trying to get the headphones around there and it's pushing on there and it hurts. There's something to be said for feeling good while you're listening to your music. And some people love to just sit there and look at the pretty lights and listen to their music and just get, float away in listening. And again, there is absolutely nothing wrong with that. And I'm even guilty of it. And I've got a IT and engineering background where I'm more focused on the form and function and the bare minimum. I mean, that's, as Lori mentioned, that's kind of my thing on our website is, we don't go for all those diamond encrusted, fairy blessed wires. We are more focused on solid engineering principles. But I do get sucked into the design and the looks. I mean, if I feel good, I'm going to listen to my music much, much more. All right, so here we've got transition a little bit into the types of cables that we have and we see in audio today. I'm sure everyone's room looks just like this, where actually this is, I mean, this isn't a picture of my basement, but this is kind of what it looks like right now, where I've got cables all over the floor and different types that I'm, testing out or prototyping or, and I've got a whole entire stack of storage drawers with nothing but cables in it as well. But here's some of the types that we see when we're hooking up our gear. There's power cables, signal cables. That's basically, the interconnects that you use to connect your gear. Speaker, headphone, and then of course we can't forget, for the analog lovers out there, the tone arm cables that can be swapped out as well. And we are not going to talk on we're not going to talk on Toslink as well, because that's an optical style of connector. And it's kind of a unique type of connector that we're not going to be walking through today. So first off, power cables. So really, the key material property here for most power cables is going to be that low resistance. You really want that high energy, that high amount of power to be pushed through the cable with the least resistance possible. And some of the reasonings why you see power cables being so big is because if there's too much resistance and you're pushing that much current through there, then it can generate heat. And the last thing you want is overheating with your audio gear. Obviously, that is in a very, very extreme case. Pretty much any power cables that you see out there in the market today are going to meet or greatly exceed what your gear is capable of pulling. But you do want to make sure that you match the cables based off of what it says on the device that you're plugging it into. Especially extremely powerful Class A amplifiers, monoblocks. You definitely want to make sure that you're not using a, small gauge wire to plug that into your, whether it be your wall mains or your power conditioner, because it was going to want a wider road for that power to drive on, is what we're looking at here. And also having a lower resistance in power cables minimizes the voltage drops as it's pushing that power through. So as we're going over this as well, I know, Brian, you're on the call, physics professor and guru. If there is anything in here that you want to either clarify or add to, definitely jump in, or anyone else on there. I know we have a lot of people with various backgrounds. If there are any other experts, definitely jump in. If there's something that's either missing or needs to be clarified, any and all comments are welcome.
There are some questions in the chat. Someone's asking about power cables and like if the sonic differences in power cables are RFI related. And I have to confess, I have not done a deep dive into the power cable side of things. I've looked mostly at signal cables, trying to understand what's going on there. I do know that with power cables, yes, your EMI generally, just electromagnetic interference, whether that's radio frequency or otherwise, like that's a big one. I think there is more to it with power cables, but again, that's one of those things that I haven't personally done a deep dive on yet. So carry on.
I mean, to be honest, I mean, myself as well, I've been focused on more of the interconnects as well as the headphone type of cables in regards to, designing and building and manufacturing. But to your point, the one thing I did notice in my own listening, just, as part of the hobby, as you touched on, Brian, was that shielding, is that they are generators of interference. And I did find that I had a lot less hums, a lot less issues with my interconnects once I actually upgraded to shielded power cables. They weren't super expensive, super crazy, top of the line power cables, but they were a step up above the run of the mill ones that you find, on Amazon and, in Best Buy today. So that is one thing that I definitely noticed as well, was the shielding made a big difference on how it interacted with the other appliances that were in my listening system. And one of the things, is, and that last point too, in regards to sonic capabilities. And again, someone jump in if this is not right or correct, but that lower resistance minimizes the voltage drop. So that way, if it's wide enough of a channel for all of that power to get through and the voltage doesn't drop, that's going to be a lot less work for that power supply to adjust that voltage and for your device to operate at a certain voltage at a certain level for that's coming in. I know power supplies have come a long way, and it may be a moot point, but it does allow for that more consistent and make sure that, no lack of power is getting through. Does that make sense? All right. Interconnect cables. So with interconnect cables, one of the main properties, the material properties of a particular conductor that you want to be focused on typically is the lower capacitance. So capacitors and whatnot are typically used for like low pass filters and things along those lines. And you want to make sure that all the frequencies, all the sound is getting from point A to point B. And since the connected gear is extremely high impedance, then resistance really matters less, and capacitance becomes more of what you want to look for interconnect cables. Now, again, keep in mind here that interconnect cables are not amplified, so they're very small signals. So any EMI, any interference, any tweak to that signal is going to make a large difference once it's amplified by your preamp and then finally by your power amp. So interconnects are where you really want to protect that signal. You want to make sure that you have a pure signal from your source all the way to the next device in the chain. And that's where shielding comes into play too, is a lot of interconnects, especially RCAs, where they're, by definition, they're unbalanced. You want a lot of shielding around there and multiple layers of shielding to really make sure that nothing gets past that set of armor for electromagnetic interference and radio frequency interference as well. And then obviously with having it be with coax, with most of the RCA interconnects, is the dielectric or that insulator is important to make sure that there is no signal that's being transferred from one cable to the other, to avoid things like crosstalk and things like that. But one of the things, as we mentioned in the last section here, is that balance cables, in addition to balance design and differential design within the amplifiers and preamps and having that design be fully balanced from start to finish, one other benefit that you gain from balanced is canceling out the noise going across the cables, because it actually sends two signals from the beginning to the end. And one is the standard signal, and then one is basically the inverted polarity. So then that way, once it goes all the way down the entire line, any frequencies of radio, or if it has any EMI, anything that's any interference that's picked up, once the two signals are flipped and put back together again, it cancels out any noise that is on that line due to interference. So that is one of the benefits of balanced connections. Now, again, I'm going to say that there are, when there's a lot of different unique differences in terminology with balanced and differential. Not going to really get into that today. But in regards to cables, it does greatly impact and make sure that that signal comes from, your source to your destination very cleanly, because it cancels out a lot of that noise. And yeah.
Jeremy, could you speak maybe a little bit in your mind how different interconnect cable designs might affect capacitance and inductance and resistance? If you talk about like a multi-strand versus solid core, or golden ratio from Cardus versus a real simple coaxial style cable. Could you speak a little bit to that?
Yeah, so we can touch it. There's a little bit more about the materials and everything, not really specific to interconnect, so I'll chat a little bit about it here. But in regards to the material selection and the designs and the geometry, which is kind of what you're referenced to, is the geometry I speak of in regards to the layers of materials, the types of materials, how everything is put together. A lot of times we typically use in interconnects, we use stranded wire just because it's flexible. You can move it around. And also with certain types of cables we'll get into later is you'll definitely want stranded for LITs types of structures, where each individual strand of that wire is coated in enamel to ensure that there is no impact on the skin effect and so forth that's talked about a lot. In regards to actual shielding and design, a lot of the higher quality for RCA interconnects, a lot of the higher quality cabling that you see has different materials or better materials as the dielectric, as a foam between the actual signal wire and then the shield or the return wire, which the shields acts as for a standard coax connection. But cheaper cables typically don't have as many layers of shielding, and higher end cables will typically have multiple types of shielding. So some will have an aluminum foil, for instance, and then have a braid of tin copper or steel or something along those lines, then another layer of insulation. Some cables actually even have layers of conductive material, so that way if there's any movement in the cable that creates microphonics, instead of that energy going into the signal and causing noise, it actually is pulled from the system by that lead wire, so that way it goes away from that valuable signal down in the middle. So there are different designs and different materials that you can use to really impact the quality of that connector. And again, later on, we'll go over, for instance, like the thicker the gauge of the wire is going to really reduce the resistance of that cable. And different things like your dielectric material that you use to separate your conductor from your shield, that's going to impact your capacitance. So it's all designing the cables and using different materials, using different types of designs to, solve the problem that you're looking to do. And in the case of unbalanced interconnects, the monster is the interference, because it's such a small signal, you want to protect that because that's the beginning of the chain and you want to make sure it goes pristinely from one component to the other. Did that help a little bit, Jim? Did that go enough into it?
Sure. But it sounds like you're going to get in some more detail later, so I'll let you carry on.
Yeah.
And
if I don't answer it later, definitely ask it again. So, So for speaker and headphone cables, similar to power, you really want low resistance. Speakers and power amps, typically compared to other interconnecting devices, they have a lot lower impedance delivery and impedance loads on it. So the key factor you definitely want to go for is resistance. And unlike your interconnects that you have, where it's just a tiny, tiny signal, this is the end of the chain. The signal is amplified at its max, and a tiny little bit of interference from the outside isn't going to be audible in most cases. So that's why, a lot of the speaker cables that you see out there today, it's 2 wires. Most of the time, it's not even shielded. Doesn't need to be shielded. For that reason, is because it's really minimally impacted by any type of interference. Now, that's not to say you want to run it right along the, right in the wall next to your AC mains, and then you'll get, some sort of hum, your ground hum or your 50, 60 hertz hum for having your signal being right next to a power wire. You definitely want to still keep it away from power wires. And if you do have to run it across a power wire, always do it perpendicular, so that way it impacts the cable the least amount. But typically, another reason why you want the lower resistance is because it's the longest part of your system. So inside of your, your source devices, your preamps, your amps, all that's wired internally, whether it be point-to-point wiring or circuit board wiring. But either way, there's not much space that signal goes through in that little device. But as soon as you go from your device, to a speaker, now you're talking about feet of signal length, where it needs to go all the way across multiple feet. And it's not inside a nice protective metal shell like most devices are. So you want to have the low resistance, so that way it can push that signal to the speaker or the headphone with as little resistance as possible. And again, there's a lot of different type of connections that you can be used. Some people love to have bare wire. They don't want any connectors in their chain. They just want to put bare copper wire right into the terminal. Some people like spades because it offers a nice contact surface that you can really wrench down on and have a nice solid surface and a nice solid connection. And then there's convenience, the ease of use, where banana plugs and pins, for instance, work really well there, where you can plug, unplug relatively easily without having to put a lot of effort into connecting your gear. And I did want to know, one thing that is important is in cable design is obviously looking at specifications for the particular type of cable that you're using in the design to really help you understand, what this cable was designed for. The people that design a lot of these wires and configurations, I mean, they've spent their whole life designing this for a purpose, or not their whole life, maybe professional career. But there's a lot of smart people that go into design these cables and putting out these spec sheets that are really important for cable builders and cable designers, so you can have as much information as you can so you can make the right design decisions. To your point of, what type of cable design, is going to impact, capacitance, in regards to, the type of conductor, and then the dielectric that you use to protect that from any of the other conductors. And all of that information you can typically find on these spec sheets. So whenever, for instance, I'm working with a new vendor, new supplier, I won't work with anyone if they don't give me a spec sheet, because I want to know that the time and effort was put into designing a cable or a piece of wire correctly. And that way I can use that to know how I want to build, my cables. So now we're going to jump into those materials that we had talked about, some of the electrical, physical properties of those materials. So running back to the beginning of, I think the first slide that we had was cables are conductors. They basically let a signal pass through their particular medium. And the signal is what goes from point A to point B. We want to really protect that signal, and the conductivity is where you really want to make sure that it goes from point A to point B without any, whether it be interference or resistance, because you really want to make sure that it gets there as cleanly as possible and there's no other artifacts or impacts on that signal. And as we talked about before in regards to like power cables and speaker cables and headphone cables, resistance is, one of the most common factors there. And we want to make sure that we match our cables properly because, again, we don't want heat to build up. We don't want anything to catch on fire. But again, most of everything that's out there today is over-designed, overkill for what we need for that reason, to be safe and be hot swappable as needed. But we do also want to, mention here with certain materials that certain materials, like for instance, copper oxidizes in the air, turns that green color. Sometimes, again, you'll see copper that's coated, whether it be with lits or with PVC coating or Teflon coating or whatever, silicone coating, whatever they want to coat it with. And really that's to protect the wire from oxidizing, from touching that air and turning into a copper oxide, which is less conductive. And again, the whole focus on designing a cable is making the cable as conductive as possible. And that's where you'll see in some of the cheaper cables is they might use high quality cable, or wire. They might use some components, but if it's soldered and if it's not sealed properly, then over time it could corrode if it's if it's open to air and whatnot. So usually what you want to do when building cables is to really seal up all of that wire, all that material, so that way no oxygen can get to it, so it can't react and corrode over time.
Hey, Jeremy, there's a couple of questions in the comments about your use of the term hot swappable. Can you explain that real quick?
Sure. It's really just cables that that you can basically plug and unplug. So for instance, you've seen home theater in a box where cables are, directly attached to speakers and the components. So basically what I say hot swap is basically you can plug, unplug the different wires and connect your gear as effectively as possible. That's what I mean by hot swap. Been talking a lot here over the last, I don't even know what time it is now, last hour or so. So if my use of hot swappable was different from what I just mentioned, call me out on it. Let me know what I was talking to in reference to, and I'll try to clarify later as well.
I think some of the confusion might be that hot swappable generally means like you can swap something while it's in use and like while it's running.
Like a hard drive hot swappable.
Yeah.
Yeah, we don't want to do that. Do not don't plug, unplug. Yes, thank you. Yes. I highly recommend not unplugging and plugging your gear while it is turned on.
So I think you were probably getting at might want something that's quickly swappable, like a banana plug is swappable faster than a bare wire.
Correct.
Yeah. Okay.
Yes. Thank you. Yes. That is very important. So thank you to whoever asked that question, because yes, that's important. I just more or less mean the ease of use of connecting your equipment overall, not plugging it while it's on and running. Especially some tube gear doesn't like it when there's no load on it. So do not recommend that. Very important to note at the bottom here is cables can only pass what they're given. So source and destination are extremely, extremely important. So some of the things to keep in mind here is there's a lot of wiring and a lot of movement of that signal throughout the devices, through your source, through your preamp and your amp. And again, all that internal gear passes that same signal that you're going to pass through the wire. So a competently designed piece of equipment on both ends of your cable is extremely critical for your cable's performance as well. So if you've looked at cables, you've probably heard of the IACS. It's the International Annealed Copper Standard. Basically in 1914, a bunch of smart people at the U.S. Standards Bureau came together and said, we really need to come together and put together a standard for conductivity and how we use it in industry and in commerce today. So they came out with the standard. They had different refiners and manufacturers send them in various types and various grades of copper, and they analyzed it, and along with other materials. As you'll see here, like, the core metals that you typically see in manufacturing and industry today, and they performed tests on it to see how well it conducted energy. So some of the things to look at here, and the very unique things, is overall, the top couple of items with different grades of silver and copper, they're actually pretty close, and then it drops pretty dramatically once you get into some of the other metals. I did put a couple of different charts here, and you will notice that some of these differ in numbers. And there's a reason why I put this up here, is because there have been a lot of advances over the years in refining and increasing that purity of the materials, that this 1914 standard didn't really catch up with. So back then, this was referring to the standard grade annealed copper, as we call, I think it's just 99.9% or 3N copper that we see today. And then obviously over time, there became oxygen-free copper. And as you can see, there's a little bump in conductivity there. And one thing to keep in mind is this is a relative scale. So basically, copper is 100%, and everything else is based off of that standard. So if silver is the most conducting material out there, why don't we use it? Well, sure, you're aware silver is cheap or expensive compared to copper, which copper is not super cheap today, but it's a lot cheaper than silver. Looking at the silver prices over the last year and analyzing, it was 100 times the cost. So that's why your silver-plated cables, your pure silver cables, are way more expensive than your standard copper. And if you look at it, you gain a couple percentage points of additional conductivity, but that's really, really all you gain.
Jeremy, conductivity aside,
Yep.
do you have any theories, or can anyone talk about why copper cables versus silver cables have certain perceived tonal differences? Copper being warmer, silver maybe passing higher treble or higher frequencies more easily, or at least that's the way it appears. Can you speak to that?
Yeah, I can talk a little bit about some of the, concepts and theories behind that. So a lot of times they say, since silver is much more highly conductive, and with the skin effect, a lot of the higher frequencies and whatnot will go towards the outside of the conductor. They say that, to make your cable a little bit brighter, you want to add some silver so that with the higher frequencies conduct faster across that cable to brighten up the sound, versus copper as the standard, it'll be more warm or neutral, because it's all the same conductivity. So it's basically one material. Whereas if you do silver plated copper, then you can have different frequencies that might attune to that silver layer. The higher frequencies go across that, whether it be cleaner, faster. I think that's the concept, or the idea behind that, and having silver plated cables, is that it conducts higher. So effectively some frequencies will be passed, or not only just passed, but enhanced, because of that material property. So that's where, a lot of times you see these materials and cables is, there's a lot of testing and a lot of experimenting going on with how cables sound. So that would be my thoughts on it. I mean,
So
that's a great question, Jim. Let's open it up. Like, I mean, I think this is a great stopping point to, let a couple other people jump in and, give their experience with the different materials and cables.
well, I will read something in the chat by Wave Theory, and he said, quote, easily explained, trickier question than you realize, but silver is naturally higher in capacitance than copper, so it naturally acts as a mild high-pass filter, often why copper sounds warmer to many. Um, Silver is also slows higher frequencies less than copper does. Neither copper nor silver have much impact on the magnitude of signal loss. So
So
that
this would be a signal loss then.
Yeah, I can try to flesh that out a little bit in
Sure.
there. Like that, the question was asked as I was typing that response.
That's interesting because I thought it was the other way around, where a lot of people thought silver was less warm, and then it gave a higher tone than copper did.
That's how I understood it too. That's why I say
Oh,
copper
okay,
often
okay,
sounds warmer. Yeah,
okay.
yeah. So usually, okay. So all of this stuff, all of our music, when it's in electromagnetic form, it's traveling as an electromagnetic wave, right? Like that's what's going through all of their cabling, but at least the signal cabling. Power cable is a little different.
Yeah.
But through the signal cabling, it's alternating current electromagnetic waves. In a vacuum, all of those waves at all frequencies would be traveling at the speed of light, right? Through physical conductors, electromagnetic energy slows down. It does not travel at the speed of light. Like copper, on average, electromagnetic energy travels through it at about 85% the speed of light. Silver is a little bit faster. Okay. Now the other thing about this is different frequencies will travel through matter at different speeds. Like the easy example for that is like why we have rainbows, right? You take white light, it's incident on a prism. The different frequencies of light will travel at different speeds and separate out, giving you that rainbow. Okay. A similar effect happens even at relatively low frequencies through the audio band. Somebody mentioned Belkin's iconoclast cables, I think, somewhere in the chat. Yeah. They published a white paper, Belkin did a while ago. I think Galen Garris was the author, where he was able to show that there were different rates of travel of the different frequencies through the audio band. And specifically, the higher frequencies travel faster than the lower frequencies, right? So hilariously, that means that the higher order harmonics of whatever is causing sound, an instrument, a voice, whatever, actually reaches and travels through the system faster than the fundamental frequencies do. Which is, I think, where a lot of these differences in cable stuff comes from. Is like it does shift things around in time. Okay. And so silver, the term easy is what tripped me up with that question, because both copper and silver will basically allow the signal through with minimal signal loss in terms of magnitude, right? So you're not going to get a smaller amplitude signal through either. But the difference between, say, how fast a 100 hertz signal travels through there compared to a 10 kilohertz signal is smaller for silver than it is for copper. Did that make sense? I mean,
Yeah, no, that was perfect. I mean, that's
yeah,
amazing insight, and I love your analogy too to the rainbow. I mean, that really, I have a similar example with actual crystals and quartz crystal and light going through it versus microcrystalline structures, and that's similar concept as well when we get to the OCC and purity component of it. So yeah, no, that was very insightful. Thanks, Brian. Any other
yeah.
follow-ups or questions on that? We'll have Brian answer it. This is why we have a physics professor on these calls.
I'll send you the bill later.
So I can just
I think you cut out, Brian.
I could just tell you one of my experiences.
Sure.
So I had a stereo that I had in my house for years and years and years. And I had it hooked up with, zip line, lamp cord, whatever, to the speakers. And I wanted to upgrade my stereo. So I went out and bought some speakers, and the guy sold me some Nordos White Lightning, basic speaker cables. I think they're silver. I'm not sure. So I'm not a physicist and I'm not a cable expert, although I work with cables because I work at the phone company and we got nothing but wire over there. And but anyway, I hooked them up and it was a remarkable difference. And I was like, well, who knew?
Yeah.
So I got on the kind of the cable matters bandwagon. And I don't have anything really expensive, but I know they do sound different. And I thought I was nuts because they were like $250 for some speaker cables. I was like, man, what kind of voodoo is this? But anyway, there's another YouTuber that went on this whole half-hour rant about how cables don't matter, and he's an expert in the physics of it and the wire of it and everything. And I'm just like, dude, they sound different. I hear a difference. I mean, I work at the phone company too. I get it, but it was like,
I mean, everyone experiences things differently, and that's a great point. And there is a comment somewhere in the presentation. I don't know where it is, but basically, what's audible to you is what makes the difference. Is in regards to what you want to do with cables. Do you want to, just use, standard cables? Do you want to upgrade it and try things out? It's all about experimenting and finding out, what fits your setup, and that synergy is important. I mean, I started building cables with a idea. I know I talked to Lori about this on one of our calls. Is I started thinking, all cables are the same as long as it's relatively decently built and, with quality materials and that's built and constructed properly. Cables shouldn't sound any different. And I've learned, over the years in audio where different things, sometimes I can't explain. I don't know why, but there are different perceived differences, and whether it be, did I have, one too many whiskeys that night or whatever it may be. But either way, it seems like something made a difference. And there's times where when I swapped out amplifiers with my different speaker sets, is obviously there's, it's a whole nother conversation with matching amplifiers to speakers, and vice versa, and your equipment. But that was kind of the eye-opening event for me, was like, wow, I thought all amps sounded the same. They're all supposed to sound the same. Their job is to amplify a signal. That's it. And why the hell did this amplifier just bring out so much life into my speakers? And then I started thinking, maybe the numbers aren't everything. Maybe they are in some things, but maybe they aren't in some things either. And that's where, it's the whole concept within audio, the yin and the yang, the analytical side of me that I've grown up and, worked my whole life. It tells me, there is no difference in cables. There's no difference in amps. But then you look at it and you hear it and you do blind tests. And you're like, there's something, I can't put my finger on it. What? I don't have all the, beautiful verbiage that a lot of the reviewers and everything out there have. But it's like, there is something going on there. And, maybe there's some sort of interaction that we haven't found yet, or maybe, like I said, maybe in a blind test or double blind, I wouldn't be able to figure it out. But I've done, blind tests where I close my eyes and have someone plug and unplug things and not tell me what it was, and did that over and over and documented the results. And it was very clear that something was found. But I mean, then there's people who could say, well, do you have enough samples of that data? You know, what was your N value and things like that? If I know probably you want a sample of 30 or above to make it statistically relevant, but long story short, basically is I became, you know, I wouldn't say a massive cable evangelist, so to speak, because I still believe that solidly engineered and designed cables, um, you know, are really what you need. But it is important to experiment to see if something matches your particular setup. And don't be afraid, you know, don't let anyone else dissuade you one way or the other. You know, if it sounds great to you, let it be. Don't buy the best cables in the world, you know, if it doesn't make a difference. And if you like to tweak, you like to try things out, if you like different things, you know, upgrade your cable, you know, try something different. That's the best part with any hobby is you get to experiment. I mean, you know, you see people in different hobbies and, you know, race cars or motorcycles, you know, they add different, you know, pieces to their gear to drop it, you know, drop their weight by an ounce. Is it really going to make that much of a difference? No, but they know they're into it. That's what they love to do. And, you know, same thing with audio. You know, it's fun sometimes to just experiment with things and try things and see if it can get that eye-opening moment that you had just mentioned there. So thank you for sharing that. All right, so in regards to material selection for cables, you know, there's so many different properties that these different materials have. It's really important to pick the best material for the job. We talked a lot about, you know, copper and silver with Brian, you know, in regards to, you know, their conductivity and, you know, what's best there. And that's why that's used for wire typically, is because it's great for conductivity. But you do want to protect the cable because both of those can oxidize. You want to make sure that it isn't exposed to too much air and humidity. And that's where, you know, plating becomes a factor for the connectors, because the connectors, they bear the brunt of the physical connecting and disconnecting of those wires. So those are the things that are going to be exposed there, that are going to be pulled and tugged on, and those are where you want to have plated with gold or rhodium, because they're non-reactive metals. They won't tarnish over time. They won't lose that conductivity due to tarnish. Rhodium is a little bit harder, not only physically harder, but it's also much more difficult to work with. I prefer gold just because it's a gold standard. It works really well, and again, it's much more conductive than rhodium as well. But some people really like that hard rhodium plating and just that nice silver look to go with that aesthetic. Brass and bronze, you know, typically used for a lot of the connectors that we use in cable making and design, because they're easy to machine. They're heavy, they're hefty, they have relatively good conductivity, but they're made to withstand all the pressures that you're going to need to push and pull and connect your equipment. Then, of course, can't forget about quality solder to make sure that you actually bond the wire to the connector properly and make sure that the two metals physically join as well, so that we can pass that signal seamlessly from the wire to the connector and into your audio equipment. I know nowadays sometimes they have they're basically cold welding, where it's ultrasonically welded components as well, where they don't use solder. That is another technology that some companies are using today. Terminology. So here's just a bunch of different lists of terminology, things that you might find in cable discussions, forums, chats, what it may be. OCC, you hear that a lot. That's basically a purification method for metals, where it's slowly pulled while the crystal is forming of that metal. So that way you get a very pure, very long grain crystal. So that way the concept is that there's less boundaries that the signal has to go through to pass it along without impeding any of that signal or having any signal loss. Cryo treatment, cryogenically treating your cables. So some people, again, the concept or idea behind this is you take material, and when something freezes, it closely aligns those atoms. Again, so that way it forms a structure and it keeps that form where, again, the signal can pass through it without as many boundaries between the individual components of that wire. Silver plated, pretty self-explanatory. Lits, that's again where we have individually coated wires. We'll dig into that a little bit further. And then we get into like the purity grades. This is what all those N's mean that you hear about, is the number of nines. So basically how many nines in percentage is it? 3N is 3 nines, 99.99, all the way up to 7N, which 7N is actually, you see it a lot advertised, but it is very, very difficult, and very few refineries actually can get to that level of purity. And not only can they get to that level of purity, but in that particular country of origin, they need to test it. And how do you verify and validate that that sample of material is indeed that purity? And then you have to send it out to a send-out lab to actually, like SGS, to do the testing on that. And a lot of labs only go up to 6N. So that's obviously, as things change, as technology gets better and better, we'll probably see those ends go up and up. But again, what's audible? What's not? Then we have a little diagram here again of just the crystalline structure of, looking at the crystals that are in standard oxygen-free copper versus continuously casted copper. And that again is attributed to Dr. Ohno, who is at the Chiba Institute in Japan, that came up with this method. Here's a little bit more about OCC. Again, the concept is that you gain the purity through that refining, but you also get that larger crystal size of the wire. And, the similar to that rainbow analogy that Brian mentioned, is, I know that's not exactly how it works, but to dumb it down a bit, with a large crystal, a crystal that is perfectly aligned internally and has a solid structure, is that the light, can go through that quartz crystal without being impeded at all, and you can see everything behind it. The light goes through it in this large crystal structure here, where it formed properly. And then down below towards the base is where you have more of those smaller microcrystalline structures that are all pieced together, and that typically bonds with the substrate underneath it. And that light, as you can see, it's diffused, it's white, the light doesn't go through there. You can't see right through there because it's being split up and diffused. Even though that's all quartz, it's all these tiny microscopic crystals of quartz. And, there may be, whether it be air or other impurities in between each of those microscopic components, it does impact that signal to go through it. So, all right, here's a PSA. I know, talk of cables. Just beware of super cheap cables. I'm not going to say that every low-cost cable out there is bad, but a lot goes into a cable. It's more than just slapping on some solder under wire and calling it done. Do the connectors fit the actual jacks that they're supposed to perfectly? How well are they machined? What materials are they made out of? How well are they assembled? If it's with machines, how tight of tolerances are there putting those cables together? How much quality control goes into that? So you may have an amazing cable, 80% of the time, but the other 20% of the time you may have a dud. So, there's different things like that you want to be aware of that goes beyond just the materials. And it's really important to know that it's not just the materials that go into a cable, but how they're all put together, how they're used. And, I do like to say, a car that's assembled, but not having any of the bolts tightened, you're not going to get very far. It's going to rattle apart and fall apart. But technically, it's using all the same materials as another car that is. or having a mechanic has their first day on the job, they're going to do a much better job, in building and designing things than, someone who's been there a while. So it's just something to think about. Wire size, as many are aware, it's AWG is what we use in America. They do millimeter cross section and whatnot in other areas. Basically, the gauge is inversely proportional to the size. So the larger the cable, you get smaller the gauge. And the bigger the cable or the smaller the gauge, you're going to get much less resistance for that particular type of material. And you really want to make sure that you don't lose power to heat and other things. So that's why you want to minimize resistance. And again, this is where, looking at the different specs that you get from manufacturers is important to take a look at it and analyze, what's going to be the best match for your system. And then I had a little bit of a diagram here that says, in extreme circumstances, for instance, if you do have too much resistance in your cable between your amp and your speaker, it can cause some changes in the frequency response where it'll actually follow the impedance curve of your particular speaker or transducer that you're working with. And if you have a completely flat impedance curve, then you got nothing to worry. It'll be pretty flat, but in real life, there's very few speakers that are out that have no change in their frequency response. So you definitely want to make sure that you size everything right. And this is where we get into that a little bit. So sizing is very important, making sure that the wire size matches your speaker load and that it's within certain limits. So that's typically what you see as a damping factor, is basically how much control does your amplifier have over that speaker. And some of the pieces that go into that is the actual speaker load, your speaker impedance load, as well as your wire that adds to that as well. So this is a table that came from you see this table online anywhere you search for speaker wire cable. This was, I think, developed by Roger Russell, who was a Macintosh engineer for many years. And this is probably the oldest source that I found, but I've seen this exact model elsewhere. But you do want to have 50-foot max. So I know in the white paper that you set up and put up, I have it linked below. You can read why it's the 50-foot max. You don't want to go beyond that because there's other physical properties and other limitations besides resistance that come into play that could impact your speakers and the frequency response that it gives. Skin effect. All right, so this is the tendency of an AC current. As Brian mentioned, audio signals are AC current that is going through these wires. And just a physical property and a phenomenon is that the signal likes to concentrate itself on the outside of the actual conductor. So basically what happens is that some of that current, some of that signal is going to the outside and then nothing's on the inside. So it's basically effectively reducing the surface area of your cable and increasing resistance throughout your entire cable. So this is where Litz wire comes into play, where basically each individual wire is coated and insulated from all the other wires. So you still get the same area of wire that the signal is going through. You get the same amount of resistance, but it allows it and basically minimize the effect of the skin effect. And I do want to note here, though, that it's typically most relevant at RF frequencies or at very high frequencies, let's say, and in the audible range of 20 hertz to 20 kilohertz. It's a non-issue for most things. Again, that goes into the do you hear it? Is it audible? Is it not? But it just something to be aware of what Litz wire is and why they use it. It's really to combat that skin effect and make sure that all the frequencies and whatnot are distributed throughout the entire wire, and you're getting that benefit of the larger wire. Cable geometry. So this is where it gets really interesting, and there's millions and millions of designs and types of materials with the size of the strands of each individual wire and how they're oriented. And I think someone mentioned before Cardis, there's a discussion they're having in a couple of weeks or a couple of months, and this is the top right image, the big circle with all the different wires of different sizes. That's from Cardis. I mean, that's their golden ratio, where they have different sizes of conductors arranged just right to maximize the potential of that wire. It's, really trying to tweak and trying to adjust the physical properties and the physics of how signals get passed by changing up the materials, by changing up the layouts, the dielectrics, the insulators, all of that stuff. That's what cable geometry is, and that's where you see so many different designs out there in the market today. And honestly, it's experiment with it. See what works best for you, because with so many options, you can't get one person to tell you if it's going to work best for you or not, because there's so much design and engineering that goes into some of these unique designs here. So Microphonics, basically this is what you hear. It's mostly and almost always with headphones. So if you're not a headphone user, you can cover your ears for this one. But Microphonics is basically when you take a wire here, you tap on it. If you have headphones on and you're moving around your desk, your wire rubs against your shirt or hits the desk, you'll sometimes hear those taps inside your headphones. So it's the same concept as if you have a tube amplifier. If you tap on the tubes and you hear the sound of the tap through your speakers, that's Microphonics. So, in cable design, again, it's most important to headphones because that's where you're moving around a lot. A lot goes into reducing Microphonics because it is a factor. You don't want to be sitting there jamming out and then all of a sudden you just hear scratching noises while you're trying to listen to your music. One thing you can do is just turn the volume up. You won't hear it because it's a steady noise, but that is something that you want to design for in headphone cables, is trying to reduce those vibrations, with different absorbing materials. And I have found that the headphone itself, how it's designed, actually impacts the Microphonics more than the actual cable. I've had one cable that sounds perfectly fine on one pair of headphones, and it's really microphonic on another. And I touch the headphone, not on the cable, and I can just hear it, and it can be annoying. Bling Bling, we talked about this before. Lots of stuff out there in the market today. Some of it looks really cool. Life is full of options. Try things out, see what you like. Some things may be technically better than another product, but if you like it and you're going to enjoy it better, go with the thing you like. If it's not something that's a critical factor for you, do it. And that's where I say, if it makes your listening sessions more enjoyable, it's worth it. I put the tubes here because the analytical side of me knows that tubes, they add distortion. They're not as clean as transistors, but the glow, and when you're watching it and you're listening to music and you see the tubes glowing, you sip a glass of scotch or your favorite drink and you're just sitting there in your chair relaxing, there's nothing better than just seeing these things glow and just that nice warmth of the glow of tubes. And that's something where it's like my rational side says I shouldn't be listening to tubes, I should be listening to solid state for the best, but there's something I just like about it. And that's okay with audio. That's okay to have, a cable that you like because you like the looks of it, or you like the feel of it, or the materials that are used. just enjoy your music. That's what this whole hobby and everything is about, is just enjoying that music. It's nice to get caught up in these details sometimes, and contrast and compare different gear, equipment, and sit there for hours listening for tiny little tweaks in your setups. But don't forget to, to actually just listen and enjoy it. So right now we'll just do a quick wrap up, and then we can go through any questions that have accumulated. Cable designs and everything are all about balance. Really want to, design for a specific purpose. Power cables are going to be designed differently than interconnects and speaker cables and so forth. And as a manufacturer, you really got to balance all the different things and all the components, materials, specifications, and try to figure out what works best for your particular audience. And you got to look at the big picture. It's how everything's put together. It's not just the individual components. It's that balancing act. And then, of course, it all boils down to what's audible to you. Where do you want to put your money? If you don't hear a difference, or if you're not bothered by it, don't spend the money on it. Put that towards something that you really like and really enjoy, and don't give into the nervosa. Just back to enjoying the music. Lessons, I kind of touched on this before. I started off with that analytical mindset, and I learned that some things aren't always what they seem to be once I started listening more and diving into the hobby more. And it's kind of expanded my perspective in what I look for in building, designing, and what I want to build in cables and different types of products moving forward. And again, it's more than just the wire. It's everything that goes into it, the love and caring, the putting it all together, the design, the thought behind it, everything put together, that really makes not just a cable, but all of your audio equipment, all of your, anything in the world. There's so much more that goes into it, than you actually see. So hopefully that's something that, we brought to this discussion, was showing you that there's a lot more thought and effort put behind building something as simple as a stupid cable. It just sends a signal from point A to point B. It can't be that, complex, right? And then just include some references as well. It's not, as I mentioned, the end all be all of all references out there today, but I did want to give everyone who is on this call a jumping point, a starting point where they can actually go through, click on some of these different references, and if they're interested in certain things, and review them. They've got them at their fingertips. This is a combination of smart people, way smarter than I am, that have spent years and years just researching and some of their best practices, and you take some of that knowledge and combine it with another experts, and you tweak and you adjust your your approach. And that's what this is about, is just, there's so much information out there. This conversation was meant to get your taste buds wet, and get you interested to dive in and learn more. That's all I got. So.
I know you have more than that, actually, because you're such a smart guy and you know everything there is to know about headphone cables. I was hoping, if if you would talk a little bit about matching headphone cables with either specific types of headphones or specific types of headphone amps. And generally, would a electrostatic headphone with an amp to match that headphone likely need a particular type of cable, or would a ribbon cable or your basic, if you could go a little bit into that, I think at least that would be something I would love to hear about.
Yeah, so electrostats are their own separate beast. So that's where you have extremely high voltage and you've got multiple wires going across there. So that's something that I don't have any experience in. That's something that I don't touch. But in regards to planars versus dynamics and whatnot, I mean, some of the key things that you really want to, go for is just the design, the build, is the sensitivity of the headphone. Because again, Microphonics, you're going to hear some of that in much more sensitive headphones where it's going to be much more proliferated across your whole system if it's amplified at that level. For sizing, so I mean, it's one of those things where you want to look for sensitivity and sizing as well, because you want a larger cable with less resistance for headphones that have lower impedance load. So say, for instance, there's some headphones out there like planars that are very low impedance. You want to have a much bigger cable for those types of loads to allow that energy to get there as efficient as possible. So for things like, extremely high impedance Sennheisers, where you get into the 300 ohm range and 600 ohms, less of an issue there. But I mean, when you're talking, some of these headphones that I've got here are like 8 ohms. I mean, they're as low as a speaker. And that's where you really want to make sure that your cable has the proper gauge, it's big enough, and that if you extend the length, if you make it longer, if your listening position is far away from your amplifier, you're going to want even bigger cable yet, a bigger gauge yet, for some of those extremely low impedance headphones, to make sure that it has that damping factor to control that speaker effectively. Because what happens if it can't control the speaker, then it'll be muddy sound. It won't have those crisp dynamics of pushing out the sound and then quickly retracting to get those transients that you really want with any speakers, whether it be headphones or speakers.
What is an average, what a gauge for headphones cables?
So typically, I mean, I would you can go. I mean, some of the cables that I've actually cut up from stock cables, I mean, they're like microscopically thin, like you can barely even see, what's in them. But I would recommend, at least 26 gauge that covers 99% of the cases out there for under 15-foot lengths. So anything, above 15 feet, if you're using 15 feet with one of those headphones I mentioned that's like 8 ohms or 12 ohms, you may want to either shrink your distance or get a beefier cable that's something, like 22 gauge or, 24 gauge, something along those lines. But most headphones today, really don't need much more than that. I mean, I do see some, headphone cables out there where they're massive, bigger than some speaker cables. And, again, if it's what you like, awesome. But I don't like all that weight hanging down on my head. I want to right size my cables so that way it doesn't add to that weight that's going to impact my listening experience. I want something that's right size, something that's, the Goldilocks, not too big, not too small, just the right amount for that particular headphone and that particular, listening distance.
I'll jump in here for just a second
Sure.
and just suggest that if any of you have questions like Jim just did, you could call Jeremy and write to him and ask your specific question. Say, I've got these new headphones and I really want to give them the best possible sound. What would you recommend? He's great for that. And also on your reference, Jeremy, you don't have your own website that I see on there. And I'd just like to tell everybody, if he's not going to promote himself, I will, that Audiophile Ninja is an absolutely fascinating and fabulous website, and his customer service is second to none. So there you go.
Thank you. Yes, I wanted this to be an informational session, and I didn't want to do any promoting at all. So thank you. Thank you, Lori. But yeah, I mean, my main thing is to be part of this community. I love to learn. There's so many smart people, and all the conversations and the different Audiophile Foundation discussions that we've had in the past, it's just great to learn. There's so many smart people out here, and let's tap that knowledge and tap those resources. I mean, God, I've learned so much from the few conversations I've had with Brian and Lori. I mean, about very different things, but it's that constant state of learning that drives me, and to be better and better. It pushes you to be better and better and learn more and more.
Hey, Jeremy, do you have any thoughts about using ferrites? That was a question that came up in the chat. I know
I have not. So I don't know enough about how those work and how it reduces the, noise and signal in there. Brian might be, maybe I shouldn't call it Brian, but Brian, if you do have an answer about using ferrites, I know they typically use that for high-speed communications, where the frequencies are much higher, and that noise is going to impact that much more than it would with signals that are in the audible range. But I don't know. Is there any other experts on the line that could jump in and answer that if it's even a need for something at the audio level for using ferrites around the wires?
Yeah, I've not really seen it in the audio band, no,
Yeah.
and I haven't really heard it make a difference. I do know that they are pretty common on HDMI cables.
Yeah, HDMI and high-speed USB, I see.
And high speed, yeah. I think that's probably just because like when you get into the the megahertz band,
range. Mm-hmm.
yeah, that's where whatever they do is probably more effective there.
Yeah.
Um,
And plus with like digital signaling and having, the square waves and the digital signal being sent across and making sure when the timing is of the rise and the fall, and that timing is so much more important with digital. I mean, a good question though, because that high speed, it's not as high speed as USB or HDMI, but digital interconnects, sends digital signals across.
well, we've got the
ferrites on there.
we've got I2S protocols these days, which I know a lot of high-end makers are staying away from because there's not a standardized protocol for that yet.
Mm-hmm.
I think PS Audio is like one of the few like high-end makers that has leaned into I2S.
Yeah.
And there's even a PS Audio standard for that. That's well known. Mm-hmm. That is like the one area then, since that uses an HDMI cable as a connector, that's the one area where maybe the ferrite cores would make a difference. I have not tested that though. That's an interesting thing, and maybe I'll have to rig up an I2S signal path and try that, because I haven't actually looked into it.
Some companies are even using RJ45 to pass instead of HDMI. I've seen that on, is it Gustard or one of the other?
That's an older standard, I think, and they're phasing that out in favor of the HDMI connector.
Got it. Okay.
Yeah.
So the thing about I2S is that it was originally not meant to be an over-the-cable protocol. It was internal. It was an internal on-die protocol for chips, and it kind of got turned into a cable protocol, which is why it doesn't have error correction or things built in like normal digital cable-based, like USB has, error correction built in. But yeah. But I had a different question, if that's okay.
Sure.
So I'm a big believer in analog cables making a big difference in sound. So I had a couple questions. One, like I just recently purchased a few like higher end silver wire interconnects because I'm trying to maximize, the sound quality between my DAC and my amp. Now, one problem I have is I have like 3 different DACs and a couple amps, and I was like, okay,
joys of being an audiophile.
Yeah. So I was thinking about putting, I have a cheaper XLR switcher in between right now, but I was thinking about building a custom high-end XLR switcher that is going to use like silver cable silver wire internally and nice, silver-based, XLR switchers, and it's going to be a pretty expensive switcher. But still, even then, it's like, am I destroying that use of the silver cable going direct from DAC to amp? I was just wanted to see what your thoughts on that were, and is it worth even using silver wire inside an XLR connector? And then my other question, in addition to that, is I know you make really nice cables. I was just reading about them and everything, and I was just curious, is there a reason why you haven't moved into making silver-based headphone cables yet?
Cost. Right now,
yeah, I figured.
In regards to, we are looking at it in the future. Right now, our company is 3 guys. So it's me and my brother and one of my friends. So we, build about 2,000 plus cables a year. We've got started from the ground up. So basically a lot of the money that comes in, we reinvest in basically buying in bulk and being able to support more and more types of headphones. So, we're very basically growing slowly, organically, and being able to build up our product lines as we move forward. So we've got two different product lines right now, one using standard professional grade 99.9% copper. Then we have our UPOCC Vanish line. And again, in the future, I would love, once the company grows, gets big, and we don't know what to do with ourselves, then once we're maxed out, then I'd love to go into some of those other materials and multi-braided designs and silver-plated copper, and really do a lot more of that experimenting with different designs. But my main thing is build it from the ground up. Make sure that every product is built solidly, and make sure that it is a good product before moving forward. I don't want to jump the gun on anything. So yes, we will eventually go into some of the more exotic type of cables and go on in the silver path moving forward. It's just a matter of when, because buying silver wire in bulk and then the connectors and all of that, I mean, it adds up very fast when when the minimum order quantities are large and we're such a small operation. So that's the one thing is, we're yearning for growth and really dying for it. So it's like, once we get to that stage where we can have more volume coming in, then yeah, I would love to keep expanding and growing the product lines. And then your other question regarding the silver switcher with XLR, I mean, I'm a firm believer of, the least amount in the signal chain as possible. So, I mean, if you can swap it, or if you do it temporarily so that we can listen to the difference, that'd be a fun project to do. But, another thing to think about is you could buy an actual switcher that's on the market today, and then just replace the wire in there with your silver wire and, silver eutectic solder or whatever you want to do for that. So that way you can, not put so much money into building the complete switcher. That's one option as well, to doing that. But I mean, long term, I have a switcher like that that's using gold contacts and copper wire. It's actually tin copper wire, and I replaced it with pure copper to do that, to do testing and to switch between different gears and to have one set of signals be sent to different amps. And I couldn't personally hear a difference, but again, everyone's ears are different. But I only use that in testing scenario. I like to just have cables as short as possible and without anything in the way, like switchers or things like that, if at all possible.
Can you talk a little bit, Jeremy, about how Audio Ninja you do your R&D when you're developing your current line of cables and looking at what I know you buy some bulk cable and you pick out best quality, and then you really figure out the best connectors and how to put them together. But what is your process for developing, your current line, or maybe something your next step of cable that you're looking at?
Yeah, I think you hit it on the head. Was really looking at what's out there today, talking with other manufacturers, other people in the industry. What are people looking at? Then going out and sourcing samples, building various prototypes, and then usually what I'll do is I'll build varying amounts of prototypes and I'll send them to people within the audio community. I've got a handful of people that I'll send it to get their thoughts on it in regards to the design, the materials. If they hear a sound difference, and understanding what type of gear they're using it with, float around and ask, what they think of it, and then make changes to it and do that iteratively. So basically our UPOCC line, I mean, I wasn't happy with, I wanted it to be perfect. I wanted every last detail to be done. It took, 2 years to get that out the door that was mid-COVID with all the supplier issues and everything going on. So there's more to it than just that. But, that's really what it is. It's an iterative process of learning, what people are looking for out there today, finding out materials that fit. So, I mean, that's really important, is designing and engineering, the wire fits into the connector, and that, there's enough space in there to put, components to reduce vibrations and vibration materials in there, and then cable strain relief, so that way it bends without breaking the internal structure of the wires, and making sure that all those pieces fit in the sleeving. It's way more work than I ever thought it would be. Let's put it that way. For a stinking cable. But it's fun. I mean, it's literally taking tons of different pieces. You can have 20 connectors and 20 types of wire and 20 types of sleeving, and trying to find a combination of all those different pieces that work well, that look well, that function well. It's a challenge. And that's kind of how I do it, is I, look what's out there today, see what people want, and then build it, design it, put my own tweak to it. And that's where we came up with the Ninja Vanish. Was, we really wanted to challenge those huge, heavy, bulky cables where people have that perception of massive, heavy headphone cables, are, can't be beaten. They're the best of the best. Well, it's like, if you look at it, it's a lot of insulation. It's a lot of, extra sleeving that really isn't needed. And it's the purity of those conductors that, are where I want to focus on. And so I made a high-end cable, hoping that people would, would like it, and appreciate the simplicity of it, and really put it in at a price that would challenge a lot of the other, cable makers today. Because I'm all about simplicity. It's like, I want to be enjoying my music, and I don't want to worry about anything impacting that experience. I want to see those tubes glow. I don't want to be thinking about something hanging on my head. So yeah, that's a little bit of insight in there. And yeah, moving forward, it's the same thing. It's like, right now we're looking at, expanding the cable line and different things like IEMs, instead of just standard over-the-ear headphones, as we're looking at researching into IEMs, and we're working with Cardus Cable on, doing a future audiophile Ninja cable, using some of their wire as our base for future products. And, they're just prototypes and everything at this stage, and we're researching it, but we've got a lot on the docket that, in the future, we'd love to release over the next few years.
Awesome. That's great.
So I got a question. Do you get on headphone.org? How would I find you?
Ninja Jeremy.
Ninja Jeremy.
Yep. But again, per Headphi's rules, if it's like business related, I can't really. I would send me an email at jeremy@audiophileninja.com.
Okay.
That will be the best, because, I can answer some things on Headphi, but per their terms of use, I can't use it to conduct business.
Well, yeah.
Yeah, but if you do see me on there, it's Ninja Jeremy is what. And again, I can't put my logo on there or anything either, so you won't know it's me unless you see the name. So
Yeah, nobody knows
Better yet, go to his website.
it's kind of the purpose of a ninja, right? It's vanish. So can't see me, don't know who I am. But
do you modify headphones specifically to buy your DT 1350s that were popular back in those days?
I do not modify, no. I know there are some companies out there that do, and have done in the past, but I don't touch the insides of a headphone. Every now and then I've done it for like 2 headphones myself, but
yeah,
it's too risky to touch other people's babies. And
well, I sent them in to get the cord repaired on them, and the rubber just deteriorates real fast on them.
Yeah.
And in the olden days, when I had a steadier hand and better eyesight, because those wires are very fine.
Yes.
I would look into doing it myself, but I still may, because there's got to be a better solution than to just keep spending money on cord replacements that don't last.
Shouldn't be. Yeah.
Do you do the threaded 1/8-inch mini to 1/4-inch XLR? That popular Sony connector that came out?
Yes.
And remember that?
The Pentacon, the 4.4 millimeter TRRS.
Well, no, it was just so it would fit in your iPod, and then it would fit in your amplifier. You know, the little quarter-inch to mini threaded thing. You could screw it on the end of your headphones, and it would change the size.
Oh, the threaded, like for something like,
Yeah, you know, like that Sony came out with it on their V6s a long time ago.
is it a threaded 3.5 millimeter?
Well, I don't do millimeters. I do
Or
eighth-inch mini
eighth inch,
plug,
eighth inch.
plug. Yeah,
Yeah, it's an 1/8 inch.
yeah.
So we do have it set up for dual. We do have a dual headphone set up for Sony's, but unfortunately, again, it's the challenge of the cable. Our core cable is so thick. For single entry cables, it's really hard to find a connector that actually will fit that wire.
Right.
You know, we do try. I would say definitely shoot me an email, and I'll take a look into that particular headphone and that design. And if it's something we can do, we definitely will. But there was so many different type of headphones out there. We try to be compatible with as much as we can, but some are just so, you know, different in their design or the materials they use. It's hard to, you know, have a sustainable product built around it.
I hear you. The interchangeable headphones, like the hi-fi mans, you know, with the connector that you could unplug and swap cables real easy. That's the gig, man. But
I like
a lot of this stuff.
I like the security of like the XLRs because they go into place, they snap, they're solid, they're secure. You know, but I mean they are a much bigger pain and it takes a lot more time to wire and solder and set up. But I mean, I love it because it's a connector that snaps into place, or those Limo connectors, Limo style connectors. I mean, those are so nice to hear that click, you know, and you know they're in there and not going anywhere. Whereas the, you know, 1/8 inch jacks or 3.5 millimeter or whatnot, it's like you can just pull them on and then, you know, and then the internal connection in there, you don't know if that pin is really on that connector or not. So and you see a lot of wear and tear in those types of connectors as well because they're pulled out and moved. It's not as reliable.
There's a lot of headphones that are just permanent wire. You can't change the connector. You can't change the cable on them.
But Grado is actually moving to removable cables now.
Yeah, I got Grados.
I've had many promises from Richard Grado he would give us a talk, but boy, he says he will, and then like months go by. I'm still working on it.
Yeah. Okay. I'll get back with you.
Great questions. Any other ones out there?
Okay, Jeremy, I've got one real quick because I'm still scratching my head over something you said, and you were talking about impedance on headphones.
Okay.
And you were saying that, say, an 8 ohm impedance requires more power than a 16 ohm headphone, right? Is that what you were saying? Talking about bigger cables for lower ohm headphones, whereas maybe I'm wrong. I always thought
you're right. It's for that damping factor. It's for that control over that transducer to make sure that it has low enough resistance that it doesn't impact the frequency response of that transducer. So basically you want to make sure, and that's the size. The size of the cable means less resistance. And if you have too much resistance, it can impact the frequency response of that driver. So that's where, you know, you want that target to be about 5% of the nominal speaker impedance. And again, there's some links and everything to the Roger Russell white paper on there that goes more into depth in how that works, and it references some of Floyd Toole's work and whatnot regarding the damping factor there. That's as impactful as it is for speakers in 2-channel setups as it is headphones. It's the same exact situation and concept there.
Thank you. That's great.
Let me see.
Any other questions from the audience for Jeremy? No, there we are. Well, that was a great talk, Jeremy. Thank you. It was a great review of cable tech.
You're more than welcome. And again, if there are any shy people in the audience as well, that do prefer communication via the electronic waves sent over the millions of wires over the internet, send me an email at jeremy@audiophileninja.com, and I will do the best I can to answer, or I can just tell you that I don't know. I mean, I'm not afraid to say I don't know something. So that's how you learn. So
I will say I love the glow of tubes, but I will push back that I think tubes are inherently superior to solid state and amplification. But I am a hardcore tube guy, so take that for what it's worth.
yeah, I love it. Love it.
Except in the summer when I heat my room up to 90 degrees. So yeah.
Yeah. That is the downfall, is the heating factor.